Hello everyone, welcome to this channel. We are studying class 11 physics. Now we are on chapter 3, motion in a straight line. Today we will understand few basic things like introduction, mechanics, what is mechanics, what are the sub branches of mechanics, basic concepts and speed, velocity and acceleration in short. Okay, and at the end we will see and I'll give you few numericals based on these topics to solve in the notebooks. So let us start with the introduction part. What is motion? Starting always with the title. Motion when any object changes its position with respect to another object with time. Right? Now this is the simplest definition of motion which you already have gone through in your lower standards. Also in the revision round we have seen this concept. What are the various types of motion? You can see in this picture also: periodic motion, rectilinear motion, curvilinear motion, translatory motion, circulatory motion, oscillatory motion. Motion is common to everything in the universe. You see, you take few daily life examples like walking, running, cycling, blood circulation in our body, flowing of water, flying birds. They are the daily life examples of motion. Now, some motions are also invisible, like for example, random motion of gas molecule. Right? You cannot see them, but there is motion in them. Flow of electrons in conducting wire. Right? When we talk about electricity or current flowing in the wire, you do not see the electrons which are moving, but this is the fact and reality that there is a motion. Right? Flow of electrons in conducting wire also, and stationary looking objects like road, trees, buildings are in motion with the earth's rotation, right? Because we are also rotating with the earth, that is why those objects like trees appear to be stationary, but this is the fact that earth is in motion, so we are all in motion, right? Even you see the sun also rotates or revolves around the Milky Way. Milky Way is also moving in respect to other galaxies. Thus, everything in this universe is in motion. The types of motion may be different. Clear? Now, moving on to a very important part, that is mechanics. Now, what is mechanics? Mechanics is the oldest branch of science that is being studied. This branch of physics deals with the conditions of rest or motion of objects which are around us. So, the branch of science that deals with the motion or concepts of motion, that is nothing but mechanics, right? One of the oldest branch of science. It is divided into three different sub branches, namely statics, kinematics, and dynamics. Now, in short, I have written statics is study of object at rest. It is the branch of mechanics that deals with the study of object at rest, or even you can say in equilibrium position. Okay, even when they are under the action of several forces, like you see balance forces from opposite side, right? If you give 4 newton on east direction and 4 newton on the west direction, that means in opposite direction the object, even if there are forces, but the object will not move, right? So in that case, if you study that object, that will be statics. Now kinematics is the branch of mechanics that deals with the study of motion of object without considering the cause. Why the motion occurred, we are not studying in kinematic, but we are studying the type of motion, right? And if you include the cause, why the motion occurred, how the motion occurred, then that will be dynamics. That will be in the part of dynamics. So three sub branches: statics, kinematics, and dynamics. Now, one fact that the word dynamics comes from a Greek word dynamics, which means power, right? Dynamics is concerned with the forces that cause motion. That is why we say that study of motion along with the cause, as we must know that what is the cause of motion? Force, right? Force causes motion. So dynamics is related to that. and Newton has contributed a lot to dynamics by postulating his famous laws of motion that we all have studied. Clear? So this was the basic of mechanics. Now, the basic concepts related to motion, but we haven't paid attention to those, like you see a frame of reference. Okay, a place or situation from where an observer takes his or her observation, right? Because frame of reference, the place from where you are taking observation, is very important, right? A very common example I'll give you. Frame of reference, you have studied graphs, you know how to plot points in the graph, right? So when you plotted the points, you took the coordinates, right? X coordinate and Y coordinate. So that is nothing but the distance of any point from the origin on the X axis. So these things you all know, right? How to take, how to plot points in the graph, right? But normally what you did, you plotted points in XY axis, right? So that was in the sense two coordinates, X coordinate and Y coordinate. So 2D representation, right? Now in physics we will add 3D representation, right? You see in this figure there is a point which is in the space, not on the plane, right? Plane over here is the graph, but over here the point is in space, right? That means it can have three coordinates, right? So that is why we have shown x axis over here, y axis over here, and another third axis that is on here. So x, y, and z coordinate. Now if you see very carefully, 3 is the x coordinate, means if you see this point over here is going towards x axis like this, and how much is the distance from origin? 1, 2, and 3. So 3 will be the x coordinate. Same way on the y axis it is 1, 2, 3, and 4. So y coordinate is 4. But on z coordinate you see 1, 2, 3, 4, and 5. Exactly in front of this it is located. So the fact of studying this is that point in space can also be represented, and that will be represented by three different axes. Now one axis you already have seen when you studied number line, right? Number line, when suppose when an object is moving in a straight manner, so can we represent the motion in on a number line, right? So that is one dimensional motion, linear motion. But when two coordinates change, it is two dimensional motion, and when three coordinates change, that is three dimensional motion, right? But when the coordinates do not change at all, the object is said to be in the rest position or stationary. Clear? Now again, another example of frame of reference I would like to give. Suppose a bag is lying in a train moving at a constant speed, right? A bag is there that is in the train, and the train is moving. Now a passenger in the train would find the bag stationary because the passenger is inside the train, the bag is inside the train, both are moving at the same speed. So even though they both are moving, but the bag will appear stationary to the passenger. Clear? Now, if the same bag is observed by a person who is standing at the stationary platform, now how shall the bag appear? The bag along with the train will appear to be moving, right? So the bag is same, but if you change the place of observation, the type of motion will be different. For a passenger, the bag is stationary. For a person standing on the platform, if he sees the moving train and the bag, the bag is in motion, right? So that is why frame of reference is very important. It is nothing like taking an origin, from that we measure the distance. Clear? Let us go for some more basic concept like distance and displacement. Now distance is the total path length traveled by any object with time. It is a scalar quantity. What does that mean? That means that distance is only dependent on magnitude, not on the direction. Distance is always positive, or even in case of stationary object it may be 0. What is the SI unit? SI unit of distance is meter. Clear? Now talking about displacement. Displacement is change in position in a fixed direction, and change in position is the real displacement. We are adding fixed direction because it is a vector quantity, right? In short, displacement is the shortest distance measured in a straight line, right? It may be found by subtracting final position and initial position. Now it is a vector quantity, so it depends on magnitude and direction. It may be negative, 0 or positive. It connects only the initial and final position, thus we can neglect the path while finding the displacement. Right? Let us take an example and see this. Now see, there is an object. Suppose an object is at B, it went to A and then to C. Right? That is why I have written B to A to C. So from B to A 3 centimeter and A to C 5 centimeter. So for reaching point C via A point, it needs to travel total 8 centimeters. So that is the distance. But when we talk about displacement, it is only B to C, the shortest distance. So you see what is the shortest distance? It is only 4 centimeter. Clear? So displacement doesn't depend on the path which is followed, but distance we have to count the every point in the path. So now I hope distance and displacement is clear. Now let us talk about the speed, velocity and acceleration. What we will do, we will see the definition, the characteristics, the SI unit, that is standard unit, the dimensional formula and then the types. Clear? So starting with speed, speed is the ratio of distance traveled by the object with time. As it does not depend on the direction, so it is a scalar quantity. As distance and time both are scalar quantity, right? Speed can be either positive or zero. The SI unit of speed, that is standard unit of speed, is meter per second. Dimensional formula is m0 l1 t minus 1, right? The types, uniform speed. So in short, I have tried to write what is uniform speed. If the object travels equal distance in equal time, so it is said to be in uniform speed. Now the opposite of that is non-uniform, that is variable speed. So we will change equal to unequal. So unequal distance in equal time, variable speed. Now what is average speed? So in average, whenever the word average is used, we will add the word total. Right? So what is average speed? It is total distance in total time. And very important, what is instantaneous speed? The speed at a particular instant of time. Now see, uh, when you see a speedometer over here, and let us suppose that it, when the journey was starting, it started from 0 and finally after 1 minute it reached to 60, right? So from 0 to 60 it took 0 to 60 second. All right, so that is 1 minute. Now you know the initial velocity or speed, you know the final speed. But if in case, if I ask what was the speed of this vehicle exactly at 35th second, right? So will you be able to answer? No. Why? Because when we talk that the car has moved from 0 to 60 kilometer per hour speed in 1 minute, we don't talk about any particular instant. We talk about a range of time, that is from 1 to or from 0 to 60 second. Clear? So what is instantaneous speed? It is the speed at a particular instant of time, right? So imagine that we are recording a video and the pointer goes from 0 to 60 in 1 minute, and exactly if we stop the video at 35th second, wherever the pointer will be showing, that will be the instantaneous speed. Clear? Now moving on to velocity. What is velocity? It is the ratio of displacement done by the object with time. It is a vector quantity as it depends on displacement. It may be either negative, positive or zero. SI unit the same, meter per second. So dimensional formula will also be same, meter m0 l1 t minus 1. Now again let us talk about the types. Uniform velocity. equal displacement equal time, variable that is non-uniform velocity, unequal displacement in equal time, average velocity, total displacement in total time, instantaneous velocity at a particular instant of time. Now, talking about acceleration, acceleration is rate of change of velocity of object with time. As it depends on velocity, we say that acceleration is also a vector quantity. So acceleration may be either negative, positive or zero, right? SI unit is meter per second square. That is why dimensional formula will be changed accordingly. M0 L1 T minus 2. Talking about the types of acceleration, it is uniform acceleration, means equal change in velocity in equal time. Variable, that is non-uniform acceleration, that means unequal velocity in equal time. Average acceleration, total change in velocity in total time. Instantaneous acceleration, change in velocity at a particular instant of time. Right? So basically speed, velocity and acceleration are almost similar in case how we see in the video. Definition, characteristics, SI unit, dimensional formula and the types. Clear? So now the theoretical topics of this video, that was the basic concept related to motion from our textbook chapter 3, is over. Now based on these concept of distance, displacement, speed, average speed, velocity, acceleration, let us see few questions and you will try to solve these questions. If possible, I hope all will be solving these type of questions. They are almost easy, but if not, we may be solving it in the future videos for your convenience. So let us start. See, sum number 1 is, in the figure given below, particle is moving along a circle of radius r, right? So radius OA, OB, OC and OD will be your radius. You can write r over here. Okay. Now it is starting from point A and it is moving anti-clockwise. So from A to B, B to C, C to D and D to A. Now you have to find out the distance traveled and the displacement done by the particle when it travels first from A to B, then A to C, A to D and one complete revolution. Right? So four cases and in each case you have to find out the distance traveled and displacement done. So I will give you a hint for A to B. If you see from A to B, distance we can find out it is the fourth part of the circumference, right? So if you divide circumference by 4, you may get the length of the curve. And displacement is, if you see, if you draw a straight line, it will be exactly like the hypotenuse of this right angle triangle. So try this, you may get the answer. A to C very easy, A to D and one complete revolution is also easy. So try this. Moving on to the next sum. It is very easy based on a concept like number line. A car is moving along a straight line, let's say OP from the figure. So here it is O 0 and P over here. So it moves from O to P in 18 seconds. So from O to P 360 meter in 18 seconds. So you may find the speed. And then it returns from P to point Q in 6 seconds. Okay. So what are the average velocity and average speed of the car when it goes from O to P? So one case you have to find out average velocity and average speed while O to P, and then you have to find out average velocity and average speed from O to P and back to Q. Now the thing that you have to take care is when you take velocity you have to find out displacement. So if we go from O to P and P to Q, the only displacement will be O to Q. So that you take care in mind while solving these questions. Moving on to sum number 3. A person has traveled a distance of 3 km along a straight line in the north direction. Then from that point he is traveling 2 km in west direction and then 5 km in south direction. So the magnitude of the displacement of this person would be fill in the blanks, right? So here you have to use this concept of direction. So you may start from a point, then you may go to the north, then you go in the west, and then you go in the south, right? So you only have to take care about the direction. You plot the points, draw the lines, and you finally will get the value of displacement only after drawing the perfect figure, right? The values are small, so answer is very easy, but drawing the figure will be little bit time consuming. So use your common sense and find the answer. Moving on to the last part of this video, that is the comment question. You have to give the answer in the comments. The question is, can any moving object have its displacement 0? If yes, give an example in which the object has moved but the final displacement is 0, right? So these three sums you will be solving after making notes, and then this question is specially for the comments. So that's all for today. Thank you.